generated in the EDM process. Okay, and also we have covered the working principle of EDM process. Okay, so that day uh, only few students were present, but today more strength is there. So quickly within 5 minutes, I will just recap or I will revise the working principle of this EDM process. Okay, only within 5 minutes. So in introduction, I was telling that this electric discharge machining is a thermoelectric process. Okay, thermoelectric process in which heat energy of a spark. Okay, please remember the words. Okay, this process is a thermoelectric process, and in which heat energy, that means the thermal energy of a spark, is used for what purpose? To remove the material from where? From the workpiece. Okay, but here one condition is there. Okay, or you can consider as a limitation of this process. Now that limitation is what? Here for this process, your workpiece and the tool should be made up of electrically conductive materials. Okay, your tool as well as your workpiece should be electrically conductive materials. Okay, and in this, during this process, the spark is produced between the two electrodes. Now two electrodes means what? Your tool and the workpiece. Okay, and that spark, its location is determined by narrowest gap between that two electrodes. Okay, so that gap, it is called inter electrode gap. Okay, you can see here also, here we have the gap also. Okay, this one is the your tool. Okay, and another is your workpiece. Okay, normally workpiece is connected to the positive terminal, so workpiece will act as the anode, and your tool, it is connected to the negative terminal, to the DC power supply. So negative terminal is what? Here tool will act as a your cathode. Okay, and in between that two electrodes, that means the tool and workpiece, we have to maintain the narrowest gap. Okay, and in between that narrowest gap, there will be spark will occur. Okay, and normally the duration of that each spark, it is very short. Very short means what? The entire cycle time, it is usually few microseconds. Okay, entire cycle time, it is in microseconds. So within a microseconds, you will get the spark. Okay, so within 1 minute, you can say thousands of spark will generate. Okay, and due to that sparking, material will removal of the material will happen. Okay, and normally the frequency of that sparking, no, that may be as high as just I told thousands of the spark per second. Okay, and the area over which the spark is effective, I repeat, the area over which spark is effective or spark radius is there, no? So that area also very small. Okay, but here the temperature of area under the spark. Okay, temperature of the area under the spark, that means you can consider here. Okay, I will show the another diagram. Here spark will appear. This area is of your workpiece, and this is the tool. Okay, so here in between this spark will occur. So the area in which under that spark, that is also very small, but the temperature of that area, it is very high. Okay, and due to that, or as a result, the spark energy is capable of partly melting. Okay, I repeat, the spark energy is capable of partly melting and partly vaporizing the materials from the localized area on both the electrodes. Okay, localized area means under that spark. Okay, and from that area also you will get from as well as tool, from your tool as well as the workpiece. Okay, so due to that spark energy, melting as well as vaporization will start. Okay, and the material removal, or that material is removed in the form of craters. Okay, you know that term craters now. Okay, the small fine particles which are removed from workpiece surface. Okay, so that craters will spread over the entire surface of the workpiece. okay, due to that spark energy and the melting and the vaporization. And then finally you will get the cavity, or the cavity will produce in that your workpiece, okay, and that cavity, it is normally approximately a replica of the your tool, okay, whatever the shape of the tool will be there, no, so same shape you will get, or that cavity you will get on the workpiece, okay. So I'm telling that the cavity which is produced on the workpiece, it is approximately a replica of the your tool, okay. And so that to have the machined cavity as a replica of tool, you have to take the care of the tool wear, okay, to have the machined cavity as a replica of the tool, okay, on the or in the workpiece, you have to take the care of the your tool wear. So that tool wear should be zero, okay. So we know that normal tool wear will happen due to the sparking, okay, because small material will be removed from the tool part also. So to minimize the wear of the tool, okay, the operating parameter and the polarity, okay, operating parameter that we are going to discuss today, and the polarity should be selected carefully. Now polarity means what? Okay, quickly I will take. Polarity means what? Now here, okay, in this diagram, if you see, your tool is connected to the negative terminal. That means cathode will be your tool, and anode means your workpiece. Okay, so it is called normal polarity. Okay, now if you interchange, that means if you connect positive terminal to the tool, and if you connect the negative terminal to workpiece, then that time it is called reverse polarity, okay. But now in many of industry, as well as for the machining operation using this CDM process, normal polarity it is used, okay. Now in case of the normal polarity, what will happen? Material removed from the workpiece, that will be higher than the your tool, okay. So only uh, less amount of material will be removed from the tool, okay. So normal polarity is essential, okay. If you change the polarity, then tool wear will be maximum, okay. And if that tool wear will be more maximum, no, then you will not get the perfect replica of the tool on the in the workpiece, okay. So that things we have to keep in our mind, okay. And normally, okay, you know that what are the part removed from the small parts removed from the or work, that particles removed from the workpiece, no, it is called, you are calling it a craters. But in case of this EDM process, whatever the particles eroded, I will say eroded from the electrodes, are known as debris, 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 okay. Craters also you can call, no problem. But for this particular process, many researchers are calling it is as a debris. Debris means what? Particles eroded from the electrodes are known as debris, okay. And normally many researchers have gone for the analysis of the debris, okay. Many researchers have gone for the analysis of these debris, and they have evaluated that debris, it is a mixture of irregular shaped particles, okay. Debris are mixture of irregular shaped particles, okay. Now how you will get that irregular shaped particles? We know the from the your melting and the vaporization. Now in that case also, again researchers, they have concluded that you will get the mixture of the irregular shaped particles as a, or from the resulting from the resolidification from the molten state, okay. Resolidification of the from the molten state, as well as you will get the hollow spherical particles also, okay. You will get the hollow spherical particle also, that you will get the as a result from the vapor condensation, okay. So this part is just I am telling for your knowledge purpose, okay. And usually the whatever the amount of material eroded from the tool surface, no, okay, is much smaller than that of the your material removed from the workpiece surface. Okay, please remember this one. Okay, कारण की काय होईल की मी आतापर्यंत सांगतोय की बाबा वर्कपीस पण मटेरियल रिमूव्ह होते आणि टूल मधनं पण इथं महत्वाचं काय स्टेटमेंट आहे, amount of material eroded or the removed from the tool surface is much smaller than that from the workpiece surface. Okay, and the normally the gap, that small gap is there, no, inter electrode gap between the our two electrodes, tool as well as the workpiece. Okay, it is lesser than hundreds of the millimeters. Okay, the inter electrode gap, it is a lesser than hundredth of the millimeter. Okay, now that gap means what, between the two electrodes. Okay, that we have to maintain continuously for our purpose, to have the spark to occur there. Okay, and for this purpose, tool driven normally, now to maintain that continue that inter-electrode gap continuously, same gap we have to maintain. So if you want to maintain the small gap by using the manually, okay, then it is very difficult. So to maintain that gap here, for this EDM process, we have to use tool which is driven by servo system. Okay, so using that servo system, you can continuously move your tool continuously for towards the your workpiece. Okay, so last time, or maybe during the ultrasonic machining lecture, one of our student he asked me, or I think she asked me question about this. Okay, how to maintain that, I think that time the nozzle tip distance was there, or stand up distance, and here's the same that gap, it is called IEG, inter-electrode gap. So use the here with the help of servo system, you can maintain continuously gap or constant gap between your two electrodes. Okay, got it? Again, I will in depth I will tell this point also. Okay, now how material, now we got the how spark is generated and how material is removed. Okay, now practically what happen during this process, how much power is required, that we should know. So normally, or during this EDM process, pulsed DC power supply, it is used, and that pulsed DC of 80 to 100 volts at approximately a 5 kilohertz frequency is passed through the electrodes. Okay, and due to that, or it results in the intense electric field at the location where surface irregularity provides the nearest gap, that means in that is inter-electrode gap. And when negatively charged particles, that means the electrons, break loose from the cathode surface, that means from the your tool, and that will move towards the anode surface under the influence of the electric field force. Okay, and during this movement, okay, you can see here also, during this movement, the your inter-electrode gap, that during that inter-electrode gap, electrons collides with the neutral molecules of the dielectric. Okay, now dielectric, here we are normally using kerosene, water, or some other approximate dielectric. And so in this EDM process, electrons are also detached from these neutral molecules of the your dielectric, and resulting in still more ionization, and the ionization becomes so intense that a very narrow channel of the continuous conductivity is established there. And during in that channel, you can see here also, in that channel you can see, this is channel, you can see there is a continuous flow of the considerable number of electrons toward the anode, and that of ions toward the electron. So their kinetic energy is converted into the heat energy. Okay, correct. electrical energy we have used. Okay, so here we are calling EDM process as the electrical energy based. But here, after passing that pulse that is see pulses, no, here detachment of the electrons as well as the ions, okay, from the workpiece. So that will happen, and their kinetic energy will converted into the heat energy, and hence heating of the anode. Okay, heating of the anode will take place due to the bombardment of electrons. Okay, heating of the anode surface. Anode means on our workpiece. Okay, that will take place. Okay, due to the bombardment of the electrons, and heating of the cathode. Okay, and heating of the cathode will take place due to the bombardment of the ions. Okay, so thus it end up in the movement current impulse. Okay, it end up in a movement current impulse, and result will get as a discharge. Okay, which may be as a your arc or the spark, and that spark energy rises the localized temperature of the your tool and the workpiece to such a high value, and that high value means what, that will give result either in the melting as well as the vaporization of the small amount of metal from the surface of the tool as well as the your workpiece, that means from both the electrons, and at the where that vaporization or melting will happen at the point of spark contact. Okay, so due to here also one fact is that, okay, due to evaporation of the dielectric will be there, no, the pressure in that plasma channel, that means this, it will also rises very high value. Okay, so whatever the material removed or the eroded from the workpiece and the tool will depend on the contribution in the form of kinetic energy. Okay, contribution of the electrons and the ions. Okay, so here ions from the workpiece metal, that means from the anode, and the electrons from the cathode, that plays a important role. Okay, so that sparking will happen. Okay, and normally we are using the state polarity. State means what, normal polarity. Okay, in that your tool is a negative, that means the cathode, and workpiece is a positive. Okay, while in reverse polarity, just already I told that the tool is positive and workpiece is negative. Okay, so this is about the workpiece. Now we'll start our next point, that is a EDM system. Okay, now here I have shown the components of the our electric discharge machining. Okay, EDM, you can say this as a EDM machine tool or the setup or the system, no problem. Okay, you can see also here our EDM machining chamber is there. Okay, then we need a dielectric supply, dielectric fluid. So here we have the dielectric system also. So there flushing mode of the dielectric system, the which type of dielectric we are using fluid, so that also we are going to see. Then the most important is that power supply, DC power supply. So in that DC power supply, whether open gap voltage there or waveform, pulse current, pulse current, then pulse on time. So these are the parameters which will affect the machining process. Okay, then to maintain the constant gap, that IEG, we require the servo mechanism. Okay, for the constant gap. Now to hold the workpiece, we require the workpiece holding system. Okay, normally here I will tell that only four major elements of the components are there. Now, which are the four? First is the power supply. Then second is the your dielectric supply. Third is your the servo mechanism or servo system, and the fourth is your this tool and the workpiece. That means the electrodes. So that part we will discuss here. Okay. Now, up till now, whatever I already explained or discussed, whether you understood working principle, working principle, समजलंय का मला? वर्किंग प्रिन्सिपल समजलंय का? हॅलो, समजलंय का? आदित्य मोटेवार, will you please say yes or no so that I can go for further. आदित्य,
Yes, sir.
समजले?
Yes, sir.
हाँ, योगेश पाटील, योगेश, understood or not? Whatever I have explained, no, I will tell just, I will ask about the working principle. Understood or not? Then next,
Yes, sir. Yes, sir.
Vaishali More, have you understood?
Yes, sir.
Okay,
हा
thank
सर
you.
अर्ध समजलं अर्ध
अर्ध समजलं बरं. हा, काय समजलं ते मला फक्त सांगा, रिपीट करतो मी.
स्लाइड बघायला लागेल.
तुम्ही मागचं लेक्चर अटेंड केलंय का?
नाही सर अर्ध्यातनच केले त्यामुळे समजलं नाही.
अच्छा, मी मागचंच रिपीट केलेलं आहे. ओके. पुढं अथर्व. हा, वैशाली. ओके. आता हॅलो वैशाली, जे मी
Yes, sir.
आता
मी लेक्चर
एक्सप्लेन,
बघते व्हिडिओ.
हा ओके
Sir,
ओके,
YouTube वरती बघते.
ओके, दॅट्स गुड, नो नो प्रॉब्लेम, थँक्यू.
हा ओके.
Okay. Okay. Now we'll go for the next one. Sure. Okay. Which are the main four components of our EDM process system? One is the power supply. Without power supply, our process is incomplete. Okay. Then our dielectric flushing, that is dielectric system. So there we are going to discuss the which type of dielectric fluid we have to use, how we have to flush that dielectric fluid. Then third is the your servo mechanism or the servo system. Okay, to maintain the constant interrelative gap, we require that mechanism. And the last and important, our tool and the workpiece, that is the electrodes. Now first we will discuss the okay. Now we'll discuss the one by one. 1 minute. One minute. Okay. Now first we'll start with the dielectric system. Okay, dielectric system. So in dielectric system have the subcomponents of this dielectric system. Now subcomponent is what? This dielectric system consists of the dielectric fluid, then a reservoir, then filters, pump, and the delivery devices. Okay, so good dielectric fluid should have the some properties. Okay, good dielectric fluid should have the some properties, and that properties here I have also mentioned. Okay, it should have high dielectric strength, so it should not break down easily. Okay, so it should have it should have a dielectric strength, a high dielectric strength, so it cannot with a very high voltage and high potential which are applied. Okay, then now I will explain about this also. Two important properties of the dielectric fluid are, one is the high dielectric strength. and the second is the it should remain critically non-conductive with very high voltage as well as the high potential difference. Okay, so until and unless its breakdown voltage is in between, that means it remain that what I will breakdown voltage of the is zero. So if our applied voltage will be more than that, then and then only. Hello. हॅलो. लेक्चर चालू आहे, मी नंतर फोन करतो. लेक्चर चालू आहे, नंतर फोन करतो मी. होय, नंतर फोन करतोय. सॉरी. of the dielectric fluid. So first is that it should have high dielectric strength, so it should not break down easily, and so it should have the high dielectric strength. Okay, then now the question arises, which type of the dielectric fluid we can use. So commonly we are using the dielectric fluid as a transformer oil, paraffin oil, kerosene, as well as the lubricating oils, deionized water also you can use as a dielectric fluid. Okay. The fluid has following properties. Here also I have mentioned high dielectric strength or the to as the gap immediately after the spark has occurred, so we should have the good dielectric fluid. Okay, and high fluidity. Okay, now as water that high okay, and most important that it is required for the required if you use direct fluid after you usage of that, then what will happen in that direct fluid, there may be the contamination of the your debris particle, so we need the filtration. Okay, so now how to supply the dielectric fluid. Okay, that point is or that question will arise. Now that supply means I will tell either placing of the dielectric. Okay, how to place the dielectric. So there are some methods which we can use for the placing of the dielectric. Okay. So here I have shown some diagrams also. Now in that first method is the suction through the your electrons. Okay, so suction through the electrons, or I will say suction through the workpiece, this diagram. Okay, here you can see this is your tool. Okay, and inside the tool there is a hollow. Okay, hollow is there inside your tool, and this is the hollow they have used as a hollow tube. So during the direct flushing, here direct fluid actually it is sucked and it is totally immersed into that direct chamber. Okay, here you can see through this you have to use electric fluid. Okay, and suction will happen here also. Then second is the suction through workpiece. Okay, now here you will get the hollow. and from this you can suck the dielectric fluid. Okay, suction through the workpiece. Okay, dielectric fluid through the through electrons. Okay, so this is a mostly used method, and here dielectric fluid can be delivered through the hollow tube, through the tube. Okay, through the thorough tube, and that through the tool you can see here, through the tool you can give the dielectric, and can be or I can say can be delivered into the this interelectrode gap, and then it is coming outside from this interelectrode gap. Okay, okay. In first case, direct fluid is coming like this. Okay, you can say arrow, and from this hollow tube, okay, which is in that your tool, inside the tool. So through that hollow tube you can suck. Then in the second, you can suck your direct fluid through the hollow through the workpiece. In the third, you can give the your direct flushing through the workpiece. Sorry, tool. Hollow tube will be there, and it will go like that. Then third is the pressure through pressure through workpiece. Okay. Fourth one is the pressure through the workpiece. You can see through the this hollow tube. Okay, inside the workpiece you can give the your flushing of the dielectric, and from there, then through this interelectrode gap you can send out the your dielectric fluid after flushing. Then jet flushing. Jet flushing is very simple. Okay, usage of your nozzle and jet. Okay, you can just flush out the direct fluid. Okay, then here another one is the sixth one, that is the periodic cyclic of the electrodes. Okay, now what I mean by this periodic cycle of the electron? So here you can vibrate your tool. Okay, you can vibrate your this tool with a ultrasonic vibration. So this tool will vibrate with the ultrasonic vibration, and if it will vibrate with the ultrasonic vibration, okay, so what will happen? These debris particles are there, no, at the surface of on the surface of the workpiece. Okay, so that will come out outside that workpiece. Workpiece will come outside. Ultrasonic vibration, that actually it is used here, and the flushing method it is used in the microEDM operation. Okay, microEDM operation. Okay, here so normally through pressure electrode, this method of flushing it is used. Okay, jet flushing it will give low material removal. Okay, now in this genetically corrective material. The properties of this electrodes material. So first property is that it should be easily, it should be soft material. Okay, now material is soft we know that soft and easy. So it's soft material. Then has no weight. Okay. Then okay, it should cheap really. So these
Sir,
uh,
sir, hello, sir, sir.
हॅलो, आवाज येतोय? हॅलो
हा आवाज होतोय सर.
आवाज येतो नाही?
हा जास्त काहीच कळलं नाही तुम्ही आता बोललेलं. नाही येत आहे.
आता आवाज
नाही.
येत 1 मिनिट, जस्ट आय विल चेक माय इंटरनेट. चालू आहे की सिम तुझं चालू कर. 1 मिनिट, आय विल चेंज नेट. 1 मिनिट ओनली. हा हॅलो, आता येतो का आवाज?
हा
हॅलो,
येतोय सर.
हा
येतोय.
ओके ओके. हा, इलेक्ट्रोड पासून रिपीट करू का मग?
हा ती स्लाइड
इलेक्ट्रोड
रिपीट करा सर.
इलेक्ट्रोड्स ना,
हा हा.
इलेक्ट्रोड्स. हा ओके ओके, आय विल रिपीट. Okay, now in the EDM system, first component we have discussed, that is a dielectric system. ओके, म्हणजे कुठलं डायरेक्ट फ्लुइड तुम्ही वापरू शकता. मग ते फ्लुइड सिलेक्ट कसं करायचं, म्हणजे त्याला कुठले डिझायर प्रॉपर्टीज पाहिजे. दॅट डायरेक्ट फ्लुइड कसं आपण सप्लाय करायचं, म्हणजे फ्लश कसं करायचं, त्याच्या मेथड्स बघितले आपण. ओके, आता आपण सेकंड कॉम्पोनंट किंवा एलिमेंट्स म्हणू शकता. ते कुठलं आहे तर इलेक्ट्रोड्स. आपल्याला माहित आहे की आपलं टूल ऍज वेल एज अवर वर्कपीस बोथ आर द इलेक्ट्रोड्स बिकॉज इलेक्ट्रिक. ओके, आता आवाज येतोय ना व्यवस्थित? आवाज येतोय का?
Yes, sir.
Okay.
Yes, sir.
Now we'll talk about the electrodes. Now in this EDM process, our tool electrodes, okay, it is used by means of the providing the electrical energy to the your workpiece. Okay, your tool electrode, it is used for the for purpose of providing electric energy to the your workpiece method. Okay, so here what are the basic question arises, that what kinds of the desired properties are required for this electrode. So first property is that your material should be electrode material should be easily machinable. Then it should have the low wear rate. Okay, then important that your electrode material should be good conductor of your electricity as well as the heat. Okay, and it should be that material of the electrodes should be cheap. It should be easy, readily available. Okay, now another question arises. आता आपल्याला माहिती की बाबा ह्या प्रॉपर्टीज पाहिजेत. ओके, माझा प्रॉपर्टी माहिती झाली, प्रॉपर्टी आता कुठले कुठले आपण मटेरियल यूज करू शकतो ऍज अ टूल इलेक्ट्रोड्स. ओके, तर here I have given the electrodes material. You can use graphite, copper, brass, copper tungsten, cast aluminum, copper boron, and silver tungsten. So these kinds of material you can use as the electrodes material for this EDM process. Okay, and during this process, what are the machining accuracy is there, no? So that is depend on your the form stability of the your tool. Okay, under the electric condition. Okay, so Now we'll discuss one by one that metals. Huh? Now if you take the metal, graphite metal, now it have the some properties. Now graphite, it is easily machinable through this process. Then it has a low wear rate. It have the high conductivity. But what is the main problem of this graphite is though? Although it has a low tool wear rate, no, but at a high surface finish and high metal removal rate, brittleness of this graphite, it is undesirable property. Okay, okay, because we know that at a high surface finish and high metal removal rate, property of the graphite, that brittleness, it is the undesirable property. Okay, so that is a main problem. Okay, because what happened, because of this undesirable property, that is brittleness, it is uh, it is going to break at a high surface finishing and a higher removal rate. So this graphite, it is a very brittle metal. So with a very small force also it can break. Okay, so this is the main problem of using graphite. Okay, well, at one side it has a good property of being a EDM tool, no problem, but the brittleness, that is a problem. Okay, then we'll talk about the copper and brass. Okay, now for copper and brass, it has a high it is highly stable and relatively low wear rate is there. Okay, then copper tungsten. Okay, copper tungsten. Okay, again it have the low wear rate. Okay, but it is expensive. Okay, and again this is a I will say it is not easy to give the shape on that copper tungsten material. Okay, then other thing are that cast aluminum, that next cast aluminum, boron, copper boron, and silver tungsten. So these kinds of the electrode material you can use. Okay, but normally copper and graphite based tools are used. Okay, why they are used? Because of limitations of the other materials property. So normally graphite and copper are mostly used. Okay, because of their most important property, that easily machinable. Okay, now let us discuss the electron shape degeneration. Okay, now electrode shape degeneration is what? Due to unequal generation. So because of suppose we can consider you have taken a cylindrical tool, so that corner of the tool actually your relative field intensity will be more. So this corner portion, okay, in that corner portion will be radial. Okay, means radial radius formation will be there. So degeneration will be there at the corner point. So wear out will be more at the corner point of your cylindrical tool. Okay, I will show you that diagram also. Okay, you can see here this is a cylindrical tool. Okay, I will explain that also. Now here one important point about the electrode is that we need a high finishing allowance. We have to give the high finishing allowance. Okay, and normally whatever the tool wear is there, no, so that is quantified by the wear ratio. Okay, and that wear ratio maybe vary in the range of 0.05 as to 1 to the 100 as to 1. Okay, now I will come to the point. tool wear means what? You can see this is your tool, and you can see at the corner there is a there wear happen. Okay, you can see if you consider this side. Okay, here you will get side wear. Okay, I have shown that also side wear LES. Okay, whatever the wear happen on at side, that is side. Then you can see here corner, at corner side wear happen, so that wear it is called corner wear. Okay, and end wear. Okay, so now how to calculate the wear ratio? Simple. Whatever your diameter is there, that divided by your wear, that is the corner wear will be there or side wear. So here I have shown the formulas also. Okay, now that your machine depth divided by, if you take the corner wear or the side wear, you will get the wear ratio. Okay, and from that you can easily calculate the volume wear ratio. It is which is required to calculate the material removal rate. Okay, so this point just remember. Okay, okay, I repeat. इथं आपला टूल दिसतंय तुम्हाला सगळ्यांना. त्या साईडला जर बघितलं इथं काय झालं, वेअर झालेली. ओके, सो त्याला साईडला जे झाले त्याला म्हणायचं साईड वेअर, आणि ते आपला एनएस ना डिनोट केलेले. ओके, आणि एनला जर बघितलं इथं तर त्याला म्हणायचं एंड वेअर. ओके, इनिशियल शेप काय होता इथं दिलाय बघा डॉट डॉटनं, आणि वेअर झाल्यानंतर तुम्हाला दिसतं असं कर्वेचर कॉर्नरला झालेलं वेअर आहे त्याला कॉर्नर वेअर म्हणायचं. मग जर तुम्हाला वेअर रेशो जो फाइंड आउट करायचं तर फॉर्म्युला सोपा आहे की मशीन डेप्थ काय होते तुमची, धरून झाला का इथं दिसतंय बघा तुम्हाला मशीन डेप्थ डी होते, आणि वेअर किती झालं तुम्हाला एलसी, कॉर्नरला एलसी वेअर झालेले, साईडला एलएस. सो डी डिवाइड बाय एलसी यू लीव द वेअर रेशो ॲट कॉर्नर. डी डिवाइड बाय एलएस जर केलं तर साईड वेअर, अँड डी डिवाइड बाय एलई जर केलं तर एंड वेअर रेट भेटते. ओके, and if you want to go for the calculation of volume wear rate, then you can take just the ratio of volume of the workpiece removed divided by volume of electrode consumed. Okay, so that simple formula you can use. Okay, now we'll go for the next component of the EDM process, that is okay, up till now direct system we have seen, then electrodes we have seen. Okay, tool wear in that electrode we have seen, and next servo. Okay, servo system. Now for what purpose this servo system is used? Now servo system, it is used to maintain a predetermined gap between your tool and the workpiece. Okay, whatever we want to maintain in the electrode gap now, so for that purpose we require servo system. So there is a gap voltage sensor is there in that power supply. Okay, I repeat, there is a gap voltage sensor in power supply which sends signal to the servo system. Okay, and as soon as it senses that gap between the electrodes which has been bridged by some electric conductor material, then that signal will send to the servo system. Okay, to reverse its direction. So servo system will keep till the fluid and it now the means of this process. Okay, now this servo system should be sensitive for our small momentum, then enough power to weight of the your ram or electrode or flexing forces. Okay, now repeating of the electrons. Now before refeeding, okay, I will just talk about this servo system also. Okay, I will repeat the same point. Servo system, it is used for this EDM process only. For what purpose? To maintain the predetermined gap between your tool and the workpiece. So there is a gap voltage sensor in power supply, which sends the signal to the uh, servo system, and as soon as it senses that gap between the uh, electrode, then it has been that gap between the electrodes, no? Okay, so it will bridge that gap by some electric conductive material, and signal will send to the servo system to reverse the direction. So the servo system will keep the two reciprocating towards the workpiece until the direct fluid flushes the gap, and it will clear the electric conductor. Okay, and flushing of the clear, then machining cycle time will long and vice versa. Okay, here two requirements of the servo system is that they are or small movement and enough for of the electron flushing force. Okay, now I will talk about the electrode repeating is what. As we know, to to uh, the length to be
हॅलो सर.
established or to hello
सर वॉइस ब्रेक होते.
hello वॉइस ब्रेक होतोय. हॅलो, आता येतोय का?
हा येस सर.
येस सर.
हा ओके. हा, आय वॉज टॉकिंग अबाउट द इलेक्ट्रोड रिपीटिंग. ओके, रिपीटिंग म्हणजे काय तुम्हाला सिंपल इन मराठी आवडते. काय होणार, तुम्ही प्रत्येक वेळी ते फ्लशिंग सॉरी स्पार्किंग होणार आहे, मटेरियल रिमूव्ह होणार आहे तुमच्या वर्कपीस मधनं, आणि सायमल्टेनियसली काहीतरी 0.1% मटेरियल रिमूव्ह होणार आहे कोणाकडून, किंवा वेअर होणार आहे टूलची. ओके, मग टूलची जर वेअर झाली तर मला जे डिझायर्ड ड्रिल किंवा होल पाहिजे होतं कोणावर, वर्कपीसला, ते भेटणार नाही ना. प्रत्येक वेळी काय ना थोडा पार्ट कमीच होत जाणार आहे. मग आपल्याला अॅक्युरेट जर मशीनिंग पाहिजे तर आपल्याला काय करावं लागणार आहे, ती जे टूल वेअर झालेले आहे ते भरून काढायचे. मग ते भरून काढण्यासाठी आपल्याला रिपीटिंग करणं गरजेचं आहे. ओके, इलेक्ट्रोडचं. ओके, सो व्हॉट एव्हर द reduce the length of your tool is there, no, so that must be compensated. Okay, otherwise what will happen, the length of each successive hole will be shorter than the desired one. Okay, so we have the simple option or simple way that a simple way to overcome this problem is that first we have to estimate the amount by which the electron that electrode length is reduced. Okay, किती लेंथ और किती अमाउंट लेंथ कमी झाले किंवा रिड्यूस झाले ते फक्त पहिल्यांदा एस्टिमेट करायचं. ओके, आफ्टर द ड्रिलिंग ऑफ इच होल, प्रत्येक होल ड्रिल झाल्यानंतर लगेच आपण एस्टिमेट करायचं किती टूल वेअर झालेले. ओके, अँड देन we have to increase the infeed. Okay, or we can give the tool material. Okay, we have to infeed the tool by that much amount only. Okay, प्रत्येक वेळी किती टूल वेअर झाले तेवढं अमाऊंट एस्टिमेट करायचं आणि तेवढं इनफीड द्यायचं, त्याला म्हणायचं रिफिडिंग. ओके, and but here also however your small error will get, okay, on that your final component also. Okay, so here प्रत्येक वेळी आपण जर रिपीटिंग इनफिट जर करत गेलो तेवढं प्रत्येक मेजर करायचं आणि प्रत्येक वेळी नवीन टूलवर तेवढंच मटेरियल इनफिट करायचं. मग हे जरा काय होणार की आपल्याला एरर भेटते. तर मग आपल्याला दुसरी मेथड काय तर another it is called electrode refeeding. Okay, so in this method it is used. हॅलो हॅलो,
येस सर.
हा आवाज येतोय? हा ओके, हा
हा येतोय सर.
हा ओके. हा मग मला ॲक्रोड मशीन साठी काय करावं लागलं, तर जेवढं मटेरियल रिमूव्ह झाले किंवा रिड्यूस झाले टूलवरनं तेवढं मला काय करायचंय, रिपीट करायचंय. तर म्हणजे काय काय करायचं, जिथं तुम्हाला तिथनं तुम्ही पुन्हा ऑपरेशन चालू केलं. ओके, पुन्हा ड्रिल काढला, ड्रिल
हॅलो सर. सर वॉइस इज
हॅलो,
ब्रेकिंग. हॅलो सर, आवाज येत नाही.
आता आवाज येतोय का? आवाज येतोय का?
हा
हॅलो,
सर येतोय.
हा सर येतोय.
हा हा. नाव आय वॉज टॉकिंग अबाउट द इलेक्ट्रो रिफिलिंग. तर काय करायचं, इन दिस मेथड वी हॅव टू टेक युअर टूल to the reference point where from the depth of drilling is measured. Okay, and here आता प्रत्येक वेळी तुम्ही काय करणार, रेफरन्स पॉइंटला टूल आणणार आणि जर रेफरन्स पॉइंटला मॅच नाही झालं तर काय करायचं, वरनं ते टूल रिपीट करायचं. ओके, नाउ दॅट रिपीटिंग यू कॅन डू बाय मॅन्युअली ॲज वेल एज द ऑटोमॅटिकली. ओके, मग ह्याचा तुम्हाला काय फायदा होणार आहे, तर प्रत्येक वेळी जे ड्रिल तुम्ही मशीन मध्ये आपलं वर्कपीस मध्ये जे होल पाडणार आहे ते सेम असणार आहे. ओके, सो इलेक्ट्रोड रिपीटिंग इज इम्पॉर्टंट. ओके, कळालं? So I will explain that all the elements, direct flushing, direct system, then electrodes, tool wear, and we have discussed the one more the servo system also. Okay, power supply is also important. In that power supply you have to use the pulsed DC power. Okay, having voltage 8 to 100 volt at approximately 5 kilohertz frequency. Okay, now we'll go for the next one. हा, EDM सिस्टीमचं कंपोनंट समजला सगळ्यांना? अंडरस्टूड? अंडरस्टूड or not? हॅलो, हॅलो,
येस सर.
हा आवाज येतोय? हा अजून
येतोय,
मध्ये येत
येतोय.
मला कळणार. हा चालेल. हा, आता आपण प्रोसेस बघितलं, प्रोसेस सिस्टीम बघितली ईडीएम सिस्टीम मध्ये. आता आपण नेक्स्ट जाऊ, दॅट इज ईडीएम प्रोसेस पॅरामीटर्स. ओके, सो हिअर यू कॅन सी हिअर I have shown the fishbone diagram or the cause effect diagram of this EDM process, where you get the different input parameters or you can say process parameters and output parameters. As we know that output parameters of that process output are the your material removal rate, then dimensional accuracy, surface integrity. Okay, now which are the different process parameter input process parameter? First is the direct fluid. Okay, now this direct fluid it affects the performance of this EDM process. Now in that direct fluid, your strength of your direct fluid, then viscosity of fluid, then flash point of your direct fluid, oxidation stability of direct fluid. So these all properties or the parameters will affect the performance of EDM process. Okay. Then tool material. In that tool material also, machinability, melting point, wear rate, the electric conductivity, thermal conductivity. So these parameters or the properties also affect the performance of the EDM process. And then important again, your power supply. That means the machining parameters. So whatever your applied voltage, frequency, then cycle time or that spark gap, current. So these points also affect the your performance of it. Okay. Now for this process also we have some graphs. Okay, we have some graphs also because but we don't have okay. Many researchers have gone for the different graph. Okay, they have taken the different materials, they have applied different process parameters, and they came to the conclusion. Okay, so that part you can see in the different research papers. Here I am not going to explain that because for every material at different properties you will get the different pattern of your graph. Okay, so there is a no ideal graph for this. Okay, so that's why in book also they have not mentioned the proper graph, but you can if you search some research papers for the effect of process parameters on the material removal rate or other surface finish you will get. Okay, for example for the machining or the drilling a cavity on copper plate. Okay, again if you want to measure the surface finish you can apply different input parameters, you will get the pattern. Okay, so this is about the process parameters. Now we'll go for the next, that is the capability or process characteristics. Okay, process characteristics. Okay, normally what happens, okay, so just explain the process parameter, process capabilities, characteristics. So in that first characteristic is that this EDM process we can employ for the machining any electrical conductive material irrespective of its hardness and the other machining other mechanical or physical properties. Okay, so here we should not consider see hardness and other mechanical properties. Okay, so one property is required, that electrical conductive material. So for that or on that property you can use this EDM process. Now again this EDM process can perform different kinds of operations like drilling, slotting, multiple hole drilling. Okay, then next one is that it gives the high degree of repeatability and high accuracy as well as the tolerance, taper, surface finish, but it depends on the values of your mechanical or sorry machining parameters which are you have employed. Okay, then what are the aspect ratio is there no of 100:1. during this drilling of the small holes can be achieved in the special flush of the gap. Okay, so this can be achieved by using this EDM process. So we're saying as the process capability of the process characteristic. Then surface finish mainly governed by the pulse frequency and energy per spark. Okay, so application of high discharge energy, it will result in the deeper cracks. Okay, and here using this process, whatever you will get the material removal rate, no, so that is whatever MRR actual, no, that is quite low. Okay, it may be 0.1 to 10 cube per minute. Okay, so these are the process capabilities. We can employ this EDM process for the machining of any electrical conductive material. Okay, irrespective of their hardness, mechanical properties, physical properties, and we can go for the performing of any kinds of operation like drilling, slotting, multiple holes, etc. Okay, and also this process will give high degree of repeatability, high accuracy, high tolerance, taper, surface finish, but it depends on the values of machining parameters. Okay, then what is the aspect ratio of the 100 as to 1 is there, no? During the drilling of small holes, it can be achieved using the special flushing of gap. Okay, and the important that material removal rate which is achieved by this process, it is very low or quite low. That is 0.1 to 10 cube per minute. Okay. So here I will give some idea regarding your project also. You can go for the different materials, or you can take one material. Okay, okay. You can consider as, for example, you will take the brass material. ओके, काय करायचं, एक ब्रास मटेरियल घ्या किंवा कॉपर, आणि त्याच्यावर धरून झालं की एक 5 mm तुम्हाला ड्रिल करायचे. मग तुम्ही काय करायचं, सेम ड्रिल पाडाय असेल, मीडियम असेल, काय करायचं तर तुमचं जे अप्लाइड व्होल्टेज आहे इनपुट ते व्हॅरी करून बघायचं काय इफेक्ट होते का. तुमचा इंटरलेटर गॅप जर चेंज केला तर काय होते ते बघू शकता. मग आता ह्यात पुन्हा टूल जर तुम्ही चेंज केलं, टूलचं मटेरियल, तर काय होतंय का हे बघायचं. आणि ह्याच्यावर तुम्हाला काय बघायचं म्हणजे काय कर, तुमचा मटेरियल रिमूव्ह रेट काय असू शकतो, सरफेस फिनिश तुम्हाला काय कशी अचीव होऊ शकते. ओके, अॅक्युरसी, सरफेस फिनिश, मटेरियल रिमूव्ह रेट, हे ह्याच्यावर काय परफॉर्मन्सवर काय इफेक्ट होतोय का ते तुम्ही चेक करू शकता. ओके, so these kinds of the project also you can take, no problem. Again you can go for the micro machining of any surface. Okay, using this micro EDM also. Okay, तर हे तुम्हाला प्रोजेक्टला सुद्धा उपयोग पडून जाईल. EDM मध्ये भरपूर काही करू शकता. बरेच रिसर्चर म्हणू शकता किंवा बरेच पीपल त्याने काय केलंय की त्याच्यात PhD सुद्धा केलेलं आहे. तुम्हाला रिसर्च पेपर भरपूर भेटलेले त्या EDM प्रोसेसवर. ओके, आपल्याला सिलेबसला फक्त मी म्हणतो की EDMचा आपल्याला 25% भाग आहे. आपला इंट्रोडक्शन म्हणजे वर्किंग प्रिन्सिपल काय आहे, त्याचं कॉम्पोनंट काय, एवढंच आहे. पण आपल्याला मॉडेलिंग वगैरे नाही. मॉडेलिंग म्हणजे काय की मटेरियल रिमूव्ह रेट कसा फाईन कॅल्क्युलेट करायचा आहे. ओके, त्याचा इफेक्ट कसा मेजर केला पाहिजे. ओके, सो टू go for further work or research work in this area, you can use different research paper. Try to search some research paper on the Science Direct platform, or you can refer the production technology book by HMT. Okay, so that book means what? I repeat, researchers from the CMTI research center from Bangalore. So they have gone for some research, and through that research they have written a book. Okay, so you can refer that also. Okay, if you use the VKGN book also, in that book also he has given some graphs also regarding effect of pulse time or pulse duration, and that effect of pulse duration on the material remove rate, surface finish, then relative electrode wear rate. Okay, but what are the pattern he has given in that book? No, so that is not ideal graph. Okay, he had also mentioned that name of the author and the name of the research paper and when that research paper published. Okay, so due to that, up till now, whatever I have graph shown no for the second chapter, that pattern we are getting as ideal. Okay, but for this process, if you change the process parameters, you will get the different graph. Okay, then by changing the your direct fluid also, that means if you use the mineral oil or the deionized water, what will happen? That also you can see. Okay, you can see, or you can check the by changing the flushing method also. What will happen on the performance? That also you can check. Okay. So many researchers have gone for the research in this area. Okay. Just we have to see the different research papers, and by reading the research papers, you will get definitely you will get some idea for your project also. Okay. If you read the 10 paper, only 10 paper reputed from the reputed journal related to this area, definitely you will get the some research ideas for the your paper for your project. Okay. Are you getting my point? समजलंय का? हॅलो.
Yes, sir.
ओके, इथं मी तुम्हाला आज ग्राफ का दाखवणार माहिती का? कारण की प्रत्येक रिसर्चरचा ग्राफ हा वेगळा आहे. अगेन विथ रिस्पेक्ट टू डिफरंट पॅरामीटर. ओके, प्रोसेस पॅरामीटर यू विल गेट द डिफरंट graph. Okay, different patterns. Okay, so for that purpose I here appeal that you can search some research papers, try to read that research paper related to the EDF, and by reading the research paper definitely you will get the some idea for your projects also. Okay, EDM वर okay मी इथं तुम्हाला सांगू इच्छितो that 5 वर्ष झालं मी प्रोजेक्ट कोऑर्डिनेटर आहे. तर EDM वर ओके दिस इलेक्ट्रिक डिस्चार्ज मशीनिंग किंवा मायक्रो EDM वर आजपर्यंत कुणी काम आपल्या कॉलेजमध्ये केलेलं नाही, म्हणजे युजीच्या स्टुडंटने. तर तुम्ही हे अपॉर्च्युनिटी घेऊ शकता. सोपं आहे, एवढं काय अवघड नाही यार. एक पहिल्यांदा एक 10 पेपर फक्त वाचा. 10 पेपरवरून तुम्हाला प्रत्येक पेपर म्हणून एक तर स्मॉल आयडिया भेटून जाते. बाबा सर यांनी एवढं एवढं केलं तर आपल्याला कळू शकते बाबा आपण हे जर वेगळं केलं तर काय होईल. तेच म्हणायचं तुमचं रिसर्च गॅप. मग हे रिसर्च गॅप एक 10 पेपर म्हणून काढला तर त्या रिसर्च गॅपवरनं तुम्ही प्रोजेक्ट तर तुमचा ऑब्जेक्टिव्ह किंवा प्रॉब्लेम स्टेटमेंट फायनलाइज करू शकता. ओके, आणि जर तुमचं प्रोजेक्टचं प्रॉब्लेम स्टेटमेंट फायनल झालं तर मग पुढचं मेथडॉलॉजी सुद्धा तुम्हाला फायनल करायला सोपं पडते. ओके, मग EDM वर तुम्ही काम करू शकता. मायक्रो EDM कडे जावा, काही प्रॉब्लेम नाही. मायक्रो यू हॅव टू गो फॉर द मशीनिंग विथ द मायक्रो लेवल. ओके, so that time you require the tool having the micro sizes. Okay, so you can take a micro drilling also, no problem, or tapper drilling also, no problem. Okay, आपल्या याच्याकडे सोनवणे सरांनी सुद्धा PhD हॅज केलेले. ओके, त्यांनी काय केलेलं आहे, तीच EDM प्रोसेस वरच प्रोसेस पॅरामीटरचा कसा इफेक्ट होतोय तेच बघितलेलं आहे. ओके, मग त्यांनी काय केलंय की एक 5-6 वेगवेगळे मटेरियल्स घेतलेत, प्रोसेस पॅरामीटर चेंज केलेत आणि तेच बघितलंय. आणि कन्फ्युजन मध्ये काय ते ग्राफच काढले की बाबा मी जर हा प्रोसेस पॅरामीटर चेंज केला तर त्याचा इफेक्ट सरफेस फिनिशवर, सरफेस ॲक्युरसीवर किंवा मटेरियल रिमूव्हर कसा होतोय. ओके, ते त्यांनी चेक केलेलं आहे. अंडरस्टूड. नाउ मे आय गो फॉर लास्ट पार्ट, ऍप्लिकेशन. ऍप्लिकेशन एक्सप्लेन करू का? हॅलो. हा, ओके.
Yes, sir. Yes, sir.
प्रोसेस कॅपेबिलिटी किंवा प्रोसेस कॅरेक्टर म्हणजे काय की हे मेथड सुटेबल कशाला आहे आणि काय काय आपण ह्या मेथडला अचीव्ह करू शकतो. दॅट इज कॅपेबिलिटी. साधं सिंपल मी 5 चपात्या खाऊ शकतो, ही माझी कॅपेबिलिटी झाली. ओके, आणि तुम्ही तेवढं अचीव करू शकते त्याच्यावर मला जाणार आहे ते त्याच प्रकारे प्रोसेस कॅपॅबिलिटी म्हणजे काय तिथं तुम्ही कुठलंही ऑपरेशन डिफरंट काइंड ऑफ द ऑपरेशन यू कॅन परफॉर्म युझिंग दिस इडम प्रोसेस okay but here condition is that your two electrodes should be electrically conductive metals okay irrespective of the mechanical or physical property of the work hardness. Now come to the applications. Now this EDM process you this EDM can be employed to machine any metal means what your hard material, tough material, or brittle or exotic materials, etc. Okay, but provided that it has some minimum electrical conductivity. Okay, so that basic requirement is there. Then the manufacturing of the hardened steel dies. Okay, hardened steel dies in the field of application other than aerospace, automobile, tools and machine tool components, we can use the EDM process. Okay, for our purpose to manufacture the hardened steel dies. Okay, then this EDM process it is used for making thorough cavities and miniature holes. That means the micro holes. Then another application of EDM in the die and mold engineering is also important. Okay, again this EDM process it is used in making component for plastic injection molding machine. Okay, then EDM process can be used for making die for molding, casting, forging, stamping, coining, then forming, etc. Also it can also be used to make the die for extruding wire drawing, etc. Okay, which require thorough holes. Again it is employed for tiny holes and orifices say 50 micron. Then for the fragile features that means the micro size slots making purpose you can use this EDM process. But in case of making integrate or different difficulty to machine parts, no, in case of the making integrate shaped dies, the machining time has come down to 50% or even less using this process. Okay, and so some of the industries also claim that because of this EDM process technology, die changes are also getting faster. Okay, then what are the EDM machine dies are there, no? So that are free from the burr and it have the high life as compared to dies which are made up by using the conventional methods. Okay, again it permits the use of more durable die materials. Okay, which are that means carbide, hardened steel, exotic, etc. Okay, again using this process you can obtain matte finish. Okay, during this EDM process. Okay, by minimizing the polishing time. Okay, then another one of the common application of EDM process is that for the removal of the broken taps, drills, okay, broken taps, drills, studs, reamers, pins, okay, etc. For that removal of this, we can use this EDM process. Then by using this EDM process, one can eliminate hand work. That means sharp details were present now. So we can do EDM after heat treatment also, and it can choose better die material without worrying about it's a machining problem. Okay, again it can be used to produce shapes which are extremely difficult to make otherwise, which are that squares or D-holes or splines or narrow slots and the grooves or blended features. So that type of different shapes are there now. So for that purpose also we can use EDM. Again this EDM in this EDM process no mechanical forces act as in our conventional machining present. So hence this process can be employed to machine thin and fragile components, okay, without any danger of damage due to such force. Okay, so these are the applications of this EDM process. Okay, so here uh, I have completed first process of our third chapter, that is EDM. In the next lecture, we'll see the another method, that is the wire cut EDM. Okay, same like this process. Okay, only small changes are there. Now, whether you understood this EDM process, EDM process समजले का? Say yes or no in chat box. I am checking. Understood or not? Say yes or no.
Yes, yes, sir.
विश्वजित शिंदे, whether you understood? वैभव जगताप, सौरव वाडेकर, हर्षदा पाटील.
Yes, sir. Understood.
वर्किंग प्रिन्सिपल ह्या मेथडचं थोडं वेगळं आहे. ओके, कारण की आपण इथं इलेक्ट्रिकल एनर्जी वापरतोय आणि त्या इलेक्ट्रिकल एनर्जीचा आपल्याला शेवटी हीट एनर्जी मध्ये कन्वर्ट करायचं. हीट एनर्जी म्हणजे काय, ते मेल्टिंग अँड वेपरेशन. सो वर्किंग प्रिन्सिपल इज डिफरंट. ओके, अनिकेत बनसोडे, अनिकेत बनसोडे,
Yes, sir.
whether you understood?
Yes.
अनिकेत कळलं ना? धनश्री सोनवणे.
Yes, sir.
ओके, बर. आता अजून टाइम आहे, पुढचं पॉइंट चालू करू द्या. हे जरा थोडं जड झालंय. काय करायचं, पुढचा पॉइंट चालू करू द्या का कसं? पुढचा, हॅलो हॅलो, okay, no problem. I will not start the next point. I know this EDM process somewhat heavy to understand.
आयोनायझेशन एक्सप्लेन करा की पुन्हा एकदा.
बरं, आयोनायझेशन. ओके ओके. One minute. Now see, okay, this is a diagram of the working principle. Now we know that we are using we are giving the DC power supply. Now here in during this EDM process, DC is used, a pulse DC of 80 to 100 volt at approximately 5 kilohertz. That power supply is firstly passed through this tool as well as the workpiece. Okay, that means here through this electrodes, that DC pulse supply. So due to that, what will happen? It will result in the formation of electrical field. Okay, at this location where where surface integrity, surface irregularity is there, no? So there we'll get the electrical field. Okay. काय केलं मी डीसी पॉवर सप्लाय पहिल्यांदा पल्सड डीसी पॉवर सप्लाय पास केला ह्या इलेक्ट्रोड मधून. इलेक्ट्रोड म्हणजे काय टूल ॲज वेल एज युअर वर्कपीस. तिथं काय होणार आहे हे डीसी पल्सड पॉवरमुळे काय होणार आहे तर इंटेन्स इलेक्ट्रिकल फील्ड जनरेट होणार आहे. कुठं ॲट अ लोकेशन वेअर सरफेस इरेग्युलेटरी इज देअर. इथं सरफेस इरेग्युलेटरी आहे आणि जिथं ह्या दोघांचा जो गॅप आहे त्या गॅपमध्ये सगळ्यात कमी डिस्टन्स जे आहे नॅरोस्ट गॅप म्हणतो त्या तिथं ते इंटेन्स इलेक्ट्रिकल फील्ड जनरेट होणार आहे. ओके. देन निगेटिव्हली चार्ज पार्टिकल्स दॅट मीन्स इलेक्ट्रॉन्स इथले जे आहेत ना इलेक्ट्रॉन्स ओके दे विल ब्रेक लूज फ्रॉम दिस कॅथोड सरफेस. ओके. इथून तुम्हाला बघू शकता इथं आहेत बघा की हे निगेटिव्ह चार्ज जे आहेत ना म्हणजे इलेक्ट्रॉन्स ते ब्रेक लूज होणार कुठून तर ह्या टूलच्या सरफेसवरनं. ओके. फ्रॉम द cathode surface that means the tool and that whatever the break loose electrons are there no that will move toward this anode surface that means this anode means our workpiece. Okay. Under the influence of the electrical forces because here electrical field is there no. Okay. And in between this gap we have the dielectric fluid. Okay. आता इथं हे इलेक्ट्रॉन्स इथं पास व्हायला आले ह्या सरफेस का. ओके. अंडर दिस इलेक्ट्रिकल फील्ड इन्फ्लुअन्स. करेक्ट. नाउ ड्युरिंग दिस मूवमेंट इन दिस इंटरइलेक्ट्रोड गॅप ओके ड्युरिंग दिस प्रोसेस और ड्युरिंग दिस मूवमेंट इन दिस इंटरइलेक्ट्रोड गॅप हे जे इलेक्ट्रॉन्स आहेत द इलेक्ट्रॉन्स आर प्रेझेंट हिअर नो दॅट विल कोलाइड विथ द दिस न्यूट्रल मॉलिक्युल्स ऑफ डायइलेक्ट्रिक. ओके. जे न्यूट्रल मॉलिक्युल्स असणार आहेत कुणाचे तर डायरेक्ट फ्लुइड त्याच्यावर काय होणार आहे कोलाइड होणार कोणतं इलेक्ट्रॉन्स. ओके. आणि इन दिस प्रोसेस इलेक्ट्रॉन्स आर ऑल्सो डिटॅच्ड फ्रॉम दिस मॉलिक्युल्स ऑफ द डायरेक्ट्रिक. ओके. काय होणार पुन्हा ते इलेक्ट्रॉन जे बंबार्ड किंवा जे कोलाइड झालेत कुणावर न्यूट्रल मॉलिक्युल्स ऑफ द डायरेक्ट्रिक ना तिथनं ते डिटॅच होणार. ओके. डिटॅच झाल्यानंतर काय होणार आहे तर तिथं आयोनायझेशन विल स्टार्ट और आयोनायझेशन जास्त होणार इथं. ओके. कारण की इथं काय झालंय आयोनायझेशनचा कॉलम तयार झालाय ना म्हणजे इथं काय आपल्याला न्यूट्रल मॉलिक्युल्स आहेत. ओके. कुणाचे तर डायरेक्ट फ्लुइडचे पण इथनं हा पार्टिकल जे आहेत सॉरी इलेक्ट्रॉन इथं कोलाइड झाला पण इथं पुन्हा तो डिटॅच झाला. ओके. त्यामुळं इथं मोर आयोनायझेशन होणार. आता इथं आयोनायझेशन म्हणजे काय तर काय होणार आहे तर इथे एक चॅनल तयार होणार. ओके. नॅरो चॅनल यू कॅन सी हिअर ऑल्सो. नॅरो चॅनल विल जनरेट. ओके. हॅविंग द कंटिन्युअस कंडक्टिव्हिटी. इथं काय होणार आहे कंटिन्युअस कंडक्टिव्हिटी असलेला चॅनल तयार आहे आणि ह्या इन दिस चॅनल मध्ये ओके इन दिस चॅनल देयर इज अ कंटिन्युअस फ्लो ऑफ considerable number of these electrons. Okay. Okay. Flow of these electrons will be there towards whom toward this anode and that ions from the anode no that will move toward the cathode. Okay. And during this their kinetic energy is there no that will convert into the heat energy. Okay. So heating of the anode due to bombardment of these electrons and heating of the cathode. Okay. म्हणजे tool due to the bombardment of the ions of the anode that will take place. So here what will happen? Their momentary current impulse. ओके. मोमेंटरी करंट जे आहे म्हणजे कंटिन्यू मुवमेंट कारण इकडचे आयन इथं चालले आणि इकडचे इलेक्ट्रॉन इकडे येतात, त्यामुळे मुवमेंट होणार आहे इथं. आणि त्यामुळे काय होणार, करंट इम्पल्स तयार होणार आणि त्या करंट इम्पल्स मधून काय होणार तर डिस्चार्ज तयार होणार. आणि डिस्चार्ज तयार झाला म्हणजे काय, इन द फॉर्म ऑफ आर्क किंवा स्पार्क आपल्याला तिथं तो डिस्चार्ज भेटणार आहे. ओके. आणि मग इथले जे स्पार्क एनर्जी असणार आहे ते काय होणार, ते स्पार्क एनर्जी मुळे काय होणार आहे, तिथलं जे टेम्परेचर आहे म्हणजे लोकलाइज्ड एरियाचं ते टेम्परेचर वाढणार आहे. ओके. कुठलं, ह्या टूलच्या सरफेस मधलं पण आणि इथल्या वर्कपीसच्या सरफेस पण टेम्परेचर वाढणार ड्यू टू द स्पार्क एनर्जी. फक्त त्या लोकलाइज्ड एरियामध्ये म्हणजे जिथला तो गॅस कमी आहे तिथला. ओके. आणि त्या टेम्परेचरमुळं काय होणार आहे, मेल्टिंग होणार आहे किंवा मेल्टिंग ॲज वेल ॲज वेपरायझेशन होणार आहे. आणि त्या मेल्टिंग आणि वेपरायझेशनमुळे काय होणार तर स्मॉल अमाउंट ऑफ मटेरियल फ्रॉम द सरफेस ऑफ दिस टूल ॲज वेल ॲज द वर्क पीस विल बी रिमूव्ड. ओके. कळलं. जिथं स्पार्क झालेला आहे किंवा जो सरफेस स्पार्कच्या कॉन्टॅक्ट मध्ये आलेला आहे म्हणजे लोकलाइज सरफेस, तिथलं मटेरियल रिमूव्ह होणार आहे. ओके. आता कळालं.
येस सर.
अजून कोणाच काय,
प्रति क्रॅटर म्हणजे शेप आहे का ह्या ईडीएम मशीन मध्ये मोठा?
नाही 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 नाही, क्रॅटर म्हणजे काय, ते मटेरियल रिमूव्ह जे होतं ना, आता धरून चालवा इथलं जे मटेरियल रिमूव्ह झालेलं आहे बघा मोठं करू नका, ह्या सरफेसवरचं मटेरियल रिमूव्ह झालंय ना, बरोबर का. मटेरियल रिमूव्ह होत असेल ते पार्टिकल तयार होते माहिती का, स्मॉल पार्टिकल रिमूव्ह झाल्यानंतर बघा, हा त्याला म्हणायचं क्रॅटर. आणि ह्या ईडीएम प्रोसेस मध्ये ते डिब्रीज पण म्हणतात ह्याला. ओके. म्हणून त्याने क्रॅटर दाखवले बघा, दिसतंय का इथं पण क्रॅटर. जे मटेरियल रिमूव्ह झालेलं आहे इन द फॉर्म ऑफ स्मॉल टायनी पार्टिकल्स फ्रॉम द वर्कपीस or from the tool, it is called crater. कळाला. हा प्रणय.
सर कळा.
हा आपण जे स्मॉल पार्टिकल मटेरियल रिमूव्ह झालं असं म्हणतो, त्यातलं जर आपण मायक्रो लेवलला जाऊन बघितलं की बा स्मॉल स्मॉल पार्टिकल असतात त्याला इथं क्रॅटर बनते. ओके. आणि इथं त्या ह्या प्रोसेसमध्ये ह्या प्रोसेसमध्ये ह्याला डिब्रीज पण म्हणतात. ओके. जे इलेक्ट्रॉन मधला इरोजन झालं म्हणतात म्हणजे इरोडेड पार्टिकल्स किंवा रिमोट पार्टिकल. अजून कोणाचं
डायग्राम मध्ये तसं दाखवलेलं म्हणून
कुठल्या
ह्याच डायग्राम मध्ये ती वर स्फेरिकल शेप दाखवलाय म्हणून.
नाही नाही नाही, इथं काय केलेलं आहे, जे आता इथं ही जी कॅव्हिटी दाखवली हो, आता ड्रिल पाडायचं आहे किंवा जे काय धरून चाललं की मटेरियल रिमूव्ह करायचं ना, ही जी कॅव्हिटी आहे आणि त्या कॅव्हिटी मधलं जे मटेरियल रिमूव्ह झालेलं आहे, बरोबर आहे का. म्हणजे धरून प्रणय खड्डा पडलाय माहिती आहे ना, खड्डा, हे जे खड्डा पडलेला दिसतंय, मग ते खड्डा पडलाय म्हणजे तिथलं मटेरियल रिमूव्ह झालंय, बरोबर का. मग ते मटेरियल जे रिमूव्ह झालेलं आहे इन द फॉर्म ऑफ स्मॉल पार्टिकल त्याला म्हणायचं डिब्रीज किंवा क्रॅटर. गॉट इट.
येस सर.
हा अजून काय असेल ते विचारा. प्लीज डोंट लिव्ह ग्रुप.
डीआयनाइज्ड वॉटर म्हणजे काय सर डीआयनाइज्ड?
हा डीआयनाइज्ड वॉटर मी मुद्दाम तुम्हाला सांगितलं नाही कारण की मी आपल्याला इलेक्ट्रोकेमिकल मशीनमध्ये तिथं आपण डीआयनाइज्ड वॉटर वापरणार आहे, बरं का. मग तिथं ते इन डिटेल मध्ये आहे म्हणून मी फक्त तिथं काय सांगितलं की डायरेक्ट फ्लुइड म्हणून तुम्ही केरोसिन वापरू शकता, डीआयनाइज्ड वापरू शकता. ओके. हा त्या पॉइंटला मी येतो पुन्हा, एक मिनिट अशी सांगतो. डीआयनाइज्ड वॉटरची प्रॉपर्टी, एकच मिनिट. हा अजून
हॅलो सर.
हॅलो हॅलो.
हा येस सर.
हा काय काय शंका असेल तर विचारा मला.
सर ती रेझिस्टरचं काम काय असतंय ती कॅपॅसिटरच्या पुढं दाखवतात बघा ती.
हा हा इथली डायग्राम ना. हा ते आता आपल्याला डीसी पॉवर सप्लाय द्यायचा ना, डीसी पल्स्ड पॉवर सप्लाय. हा ओके. हा मग त्यासाठी जे आपण व्होल्टेज देणार आहे आणि सामान्य त्या व्होल्टेज बरोबर करंट जे येणार आहे. ओके. मग ते मेंटेन करण्यासाठी आपल्याला कॅपॅसिटर आणि रेजिस्टन्सची गरज असते, म्हणून ते दिलेलं आहे आपलं ते इलेक्ट्रिकल सर्किटचा पार्ट पॉवर सप्लायचा. इथं आपण म्हणून मी प्रत्येक ठिकाणी सांगितलं पल्स्ड डीसी पॉवर सप्लाय. ओके. पल्स्ड डीसी पॉवर सप्लाय किंवा ही जी पूर्ण जे आहे आता बघू शकता ही डीसी व्होल्टेज कॅपॅसिटर रेजिस्टन्स हे सगळ्याला तुम्ही आहे ना पल्स जनरेटर पण म्हणू शकता. ओके. पल्स जनरेटर सुद्धा. कारण आता इथं कशासाठी गरज आहे तुम्हाला सांगतो. नॉर्मली आपला एसी करंट असतो ना ते आपल्याला कन्वर्ट कशात करायचं डीसी मध्ये, आणि ते पूर्ण कन्वर्ट आपल्याला जे लागणार आहे तो पल्स डीसी करंट पाहिजे पॉवर सप्लाय. ओके. तर त्या पल्स डीसी पॉवर सप्लाय थ्रूच आपण आहे ना ते पल्स पॉवर सप्लाय आपण स्पार्क जनरेशनसाठी वापरणार आहे. ओके. मग त्यासाठी मग आपण रेक्टिफायर पण यूज करू शकतो. कशासाठी तर एक आपली जी एसी पॉवर सप्लाय असतो तो डीसी मध्ये कन्वर्ट करण्यासाठी. ओके.
सर पण हॅलो सर.
हा हा बोला की.
हा सर पण काय काय पुस्तकामध्ये जी कॅपॅसिटर आहे ना त्याच्या पुढे रेजिस्टर दाखवलाय सर.
त्याच्या पुढं
हा त्या
बरोबर.
पुढे लावला आणि ती कंट्रोल करण्यासाठी सांगितलंय, मग तीच विचारायचं.
नाही 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 एक मिनिट आता आहे का इथं आपल्याला आता कंट्रोल काय करायचं ते आपला तो सर्व सिस्टीम जे आहे तेच कंट्रोल करण्यासाठी ते लावलेलं असतं त्यात. बरोबर आहे का.
येस सर.
हा हा मग बरोबर आहे की ते सर्व सिस्टीम साठी हो जे आपल्याला
सर्व सिस्टीम साठी नाही सांगितलं सर त्यांनी.
हा
कॅपॅसिटर डिस्चार्ज होताना ते रेजिस्टर वापरला त्यासाठी असं सांगितलंय. म्हणजे टेकमॅक्स मध्ये
नाही
सांगितलं.
नाही नाही मग बरोबर आहे की हिथं पण तेच आहे की हे जे आपण डीसी पॉवर जे आहे मी म्हणलं जे पल्सड डीसी सप्लाय जे आहे तो आपण कसं इलेक्ट्रिक एनर्जी आहे ना ते आपण कशासाठी वापरतोय तर आपल्याला स्पार्क जनरेट करायचं आहे, आणि स्पार्क आपल्याला कंटिन्युअसली जनरेट होत नाही, फ्रॅक्शन ऑफ सेकंड म्हणजे मायक्रो सेकंड मध्ये ते जनरेट होणार आहे. म्हणून ते आपण कॅपॅसिटर आणि रेजिस्टन्सची गरज असणारच की. काय एक कॅपॅसिटर चार्ज झाला ओके आणि पुन्हा डिस्चार्ज टायमाला फक्त स्पार्क जनरेट होणार आहे. ओके. मग तुम्ही जे म्हणता त्यानुसार की बाबा हे जी कंट्रोलिंग आहे त्यानुसार रेजिस्टन्स लागणार आहे. ओके. बरं तरी पण प्रणय अजून इन डिटेल मी पण चेक करतो बरं का कॅपॅसिटी आता इलेक्ट्रिकलचं पार्ट मी पण लयात गेलेलं ना बरं का, तरी चेक करतो आणि नेक्स्ट लेक्चर अजून आपण ह्याच्या वाजून बोलू मग काय हरकत नाही. ओके. रेजिस्टन्सचं काम काय आहे कॅपॅसिटरचं काम काय ते आपण बघू मग सांगू. ओके. कारण की आताच्या म्हणजे माझ्या स्टडीनुसार फक्त जेवढं मला माहिती आहे ते सांगितले, अजून मी इन डिटेल बघतो मग सांगतो यात.
पोझिशन सर त्याची कॅपॅसिटरच्या आधी बसवले का नंतर बसवले.
हा ते 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 पण बघतो की बाबा आधी आधी असल्यानंतर काय होतं आणि नंतर असले ते पण बघतो. आता हे जी डायग्राम जे आहे ना ते मी एका एनपीटीएलच्याच कोर्स मधले घेतलेले, कारण बुक मध्ये वेगळे डायग्राम दिलेले त्याने. चेक करतो मी काय हरकत नाही. अजून कोण का अरे ते डिआयनोचं वॉटर वगैरे आहे ना माझ्या माहितीनुसार आता तिथं आपल्याला ही जे आहे डायरेक्ट फ्लूड तिथं आपल्याला इलेक्ट्रिक कंडक्टिव्ह ही जे आहे काय म्हणतो इलेक्ट्रिक फील्ड ओके तिथं ते कम्प्लीट करायचं ना गॅपमध्ये, तर ते जनरेट करण्यासाठी आपल्याला तिथं आयन जे असणार आहे ते आपल्याला काढायचे. ओके. सॉरी त्या डिस्टिल वॉटरमध्ये डिआयनाइज ना तर आयन रिमूव्ह केलेलं असते त्या वॉटरमधले. ओके. त्याला आपण ते डिस्टिल्ड किंवा डीआय वॉटर वगैरे म्हणते. ज्या वॉटरमधलं आयन्स रिमूव्ह केलेले असतात असं. आयन्स म्हणजे काय तर आपण त्याचं एकतर निगेटिव्ह आयन्स म्हणल्यानंतर आपण इलेक्ट्रॉन म्हणतो आणि प्रोटॉन. ओके, हा पुढे अजून विचारा म्हणजे मला एक काय तर नवीन बघायला भेटेल. ओके, हा 1 मिनिट चालू राहू द्या, मी अटेंडन्स लगेच घेतो चालू आहे तोपर्यंत. प्लीज डोंट लूज द मीटिंग. 1 मिनिट. आणि अजून एक रिक्वेस्ट आहे, जर कुणाला का आता मी अजून पहिल्यांदाच मेन्शन केलं, थोडं इडियम हे डिफिकल्ट आहे अंडरस्टँड करायला. ओके, तरी बऱ्यापैकी मी कव्हर केलेलं व्यवस्थित. तरी जर कुणाला नाही समजलं तर तुम्ही प्लीज आपण परवा दिवशी, काल आणि आज हे 15 मिनिटात 3 व्हिडिओ मी युट्यूबवर टाकलेले बघा. ओके, त्याच्या लिंक आज मी अजून एकदा पाठवतो. नाही समजलं असेल तर प्लीज एकदा बघा, एकदा फक्त बघा 3 व्हिडिओ. ओके, तरी जर नाही समजलं तर मला नेक्स्ट लेक्चरला किंवा कधी पण तुम्ही मला फोनवर किंवा व्हॉट्सअपवर विचारा काय असेल प्रॉब्लेम वगैरे. ओके, विचारत जावा. तुमच्या क्वेश्चन किंवा डाऊट वरनं किंवा क्वेरीवरनं मला काय तर नवीन स्टडी करायला भेटेल. ओके, किंवा असं होऊ नये किंवा मी सांगतोय सगळं तेवढं नको, त्याच्या बिवॉन्ड आपण विचार केला पाहिजे. कुठे गेला?